The universe had a beginning. That much we're fairly confident about. About 13.8 billion years ago, everything we know, space, time, matter, energy, emerged from a hot, dense state we call the Big Bang. But if the universe had a beginning, it raises an uncomfortable question. Will it have an end? And if so, what does that end look like? Today, we're going to explore how the universe might die, not in science fiction terms, but according to modern physics. Not with explosions and drama, but with silence, darkness, and time scales so vast they are difficult to even name. To understand the end of the universe, we first need to understand what the universe is doing right now. The universe is expanding. Every second, space itself is stretching, causing galaxies to move farther apart. This expansion was first discovered when scientists noticed that distant galaxies appear redder than they should be. That redness is caused by space stretching the light as it travels, a phenomenon known as redshift. The farther away a galaxy is, the faster it appears to be moving away from us, which means the expansion of the universe is not slowing down. It's accelerating. Something unknown is pushing space itself to expand faster and faster. We call this mysterious force dark energy, and dark energy may ultimately decide how the universe ends. One possibility is known as the Big Freeze. In this scenario, the universe continues expanding forever. Galaxies drift farther apart until they are completely isolated. Eventually, distant galaxies move so far away that their light can never reach us again. Each galaxy becomes its own lonely island in an ever-growing cosmic ocean. Stars continue to burn their fuel, but stars do not burn forever. Over trillions of years, star formation slows, then stops. Galaxies fade as their brightest stars die. Eventually, only dim stellar remnants remain: white dwarfs, neutron stars, and black holes. As time passes, even black holes begin to evaporate through a process called Hawking radiation. After unimaginably long periods of time, far longer than the current age of the universe, black holes disappear. What remains is a universe filled with cold, thin radiation and elementary particles drifting endlessly through expanding space. No stars, no galaxies, no structure, just darkness, near absolute zero, and time stretching on forever. This is called heat death, not an explosion, not a collapse, but a slow fading into nothingness. Another possible ending is the Big Crunch. In this scenario, the expansion of the universe eventually slows, then stops, then reverses. Gravity takes over. Galaxies begin moving closer together instead of farther apart. The universe contracts, temperatures rise, space grows denser and hotter. Eventually, everything collapses back into an extremely dense state, possibly similar to the conditions that existed at the beginning of the universe. In this ending, the universe doesn't fade away, it collapses in on itself. Some theories suggest this could even lead to another Big Bang, a rebirth of the cosmos, a cycle of expansion and collapse. However, current observations suggest this outcome is unlikely. The expansion of the universe doesn't appear to be slowing. It's speeding up. That brings us to the most dramatic possibility of all, the Big Rip. In this scenario, dark energy grows stronger over time, so strong that it begins to overcome every force in the universe. First, galaxies are torn apart, then star systems, then planets. Eventually, the expansion becomes so intense that it overcomes the forces holding atoms together. Matter itself is ripped apart. Stars, planets, molecules, atoms, all shredded by the stretching of space. Even space-time itself is torn. Time ends, not with silence, but with everything pulled apart at once. This is the most violent ending imaginable, but it depends entirely on the nature of dark energy, something we still don't understand. There's also a quieter, stranger possibility, that the universe doesn't truly end at all. It may continue expanding forever, changing slowly, becoming more dilute, colder, and emptier, but never reaching a final moment. In this view, the universe doesn't die, it simply drifts. Forever. What's unsettling is that we don't yet know which ending is correct. The fate of the universe depends on a few key numbers: the density of matter, the strength of dark energy, and how these change over time. Tiny differences in those values determine whether everything fades away, collapses, or is torn apart. Right now, the evidence suggests the universe is heading toward a slow, cold end, a future where time continues, but nothing meaningful happens. And yet, here we are, living at a time when stars still shine, galaxies still glow, and life exists at all. We exist in a brief window of cosmic history, after the universe became complete